Hello, this is the beginning podcast of many that I will be adding to your Blackboard course. And this intro is to help explain what exactly is dimensional analysis and how it will work for you. Dimensional analysis is a preferred method of figuring out nursing math questions. With the dimensional analysis, you reduce your chances of making any mistakes. Everything must be dimensionally crossed out. I'm going to give you some simple rules. I call them the rule of thumb to start your calculations with. Once you set up the first initial bracket, it's very difficult to make a mistake because everything is dimensionally crossed out. It all falls in a line. The first example that I'm giving you is 1 year, and you're going to calculate how many seconds are in a year, which of course makes absolutely no sense. No one would want to know that, but it gives you a good example of how everything must equal 1. Do you see how I have 1 year, 12 months, 1 month, 30 days, 1 day, 24 hours, all of them equal 1. So that's exactly how you're going to do your math questions. So you take a pencil and you cross out all the like units. For example, 1 year and 1 year, 12 months, months, days, hours, minutes. You're left with what seconds is what you're asking for. Always start with what is given to you or what the doctor or prescriber orders. So this next example, question number 1, it's asking you, or it's telling you, you have 3.5 liters. How many milliliters does that equal? So the setup, which is going to be the same for everything that you're going to do from now on, you're going to start with what is given or what the prescriber has ordered. So what is given is 3.5 liters. If liters are here, they have to dimensionally cross out. And you look at your conversion chart, and 1 liter equals 1,000 milliliters. If you cross out your like units, you're left with 3,500 milliliters. So straight across multiply. That's how you got your answer. The next question or example, the order is 50 milligrams. The pharmacy sends 25 milligram tablets. How many tablets will you give? Start with what's ordered or what is given, which is the 50 milligrams. Below that, the next bracket is going to equal 1, and what it's telling you is that each tablet equals 25 milligrams. Straight across multiply again, and get used to definitely crossing out the like units. Example involving a conversion. One of the examples above did have a conversion involved, but there are differences between questions. Below, I have added a question that has the following characteristics. Number 1, the doctor's order is in milligrams, and what you have available is in grams. Therefore, a conversion is needed to go from milligrams to grams. Here's the example below. I'm not going to read the question for you. You can actually read the question yourself. When you're referring to a conversion chart, this is something that you should have memorized. If you're at home, you certainly can use it, but when you are taking a math quiz, you're not going to be able to use it. So you need to memorize these. Again, you're going to start with what the doctor ordered, and that is 750 milligrams. Each one of these I call a bracket. So this is your bracket. This is a bracket, this is a bracket. So when you start with 750 milligrams, down below, milligrams have to be there. So if milligrams are here, milligrams have to be here. So you look in the question, what has anything to do with milligrams? You have the 750, There's nothing else that has to do with milligrams, it's grams. So you know you have to convert from milligrams to grams. So what you did is you took out your like units, which is milligrams. Now you have 1 gram here. If grams are here, they absolutely have to be here. What has anything to do with grams in the question? 0.25 grams in every tablet. So once you get done crossing out all of your like units, you're done. You have tablets left. That's exactly what the question is asking you. Straight across multiply, 750. Straight across multiply the bottom, 250. 750 divided by 250, you have 3 tablets. Again, you take a pencil, cross out everything that matches diagonally. How do you know when there's a conversion needed? That's really a good question. When the doctor's order or what is given to you does not match what is supplied to you. So again, whatever the doctor ordered and what you have on hand or what is supplied to you is not the same thing. Then you have to convert. If you use this rule, you can't add anything extra or leave anything out. Future questions will have extra added information that is not needed in the formula. Dimensional analysis will help you decide what is needed and what is extra. Here's the next example. The doctor ordered, or the doctor has prescribed 15 milligrams of medication. The medication is available in a 10 milliliter vial containing 30 milligrams in 1 milliliter. So what that means to you right now is that you have the doctor's order, you have a vial, and you also have what is in that vial. So every milliliter that you pull out of the 10 milliliter vial has 30 milligrams. In preparing the drug for administration, how many milliliters would you withdraw from the vial? If you stick with the rule of thumb, start with the doctor ordered, whatever is here, and that means unit of measure. Whatever is here must go here. So if you have milligrams on the top, you're going to have milligrams on the bottom. Always put what the drug yields, what is in the drug. It's every milliliter is 30 milligrams. So the 10 milliliter vial is extra added information. It doesn't belong in the calculation. It is not needed. It's simply telling you that there's 10 milliliters in that vial, but your only thing you should be concerned about is when you're pulling out your 1 milliliter, how many milligrams that is. So that's given to you in the question. It doesn't fit in anywhere. So if you set up this question, 10 milliliters does not fit anywhere in here. So that's extra added information. It's basically a multi-dose vial that you'll use again and again. So that is extra added information. I have another example here and another example here. So basically it's telling you there's a medication of 400 micrograms in every milliliter here, and it's also telling you that the doctor has ordered 0.2 milligrams. So right away when I look at this, I see the doctor's ordering milligrams and available are micrograms. So look at the 2 units that you're dealing with. Know that you have to have a conversion in here. So the conversion sits in the middle and it converts what the doctor ordered into what's available. Make sure that you're crossing out all your like units and you're left with what the question is asking you. The last question here. The order is 30 milligrams and you have the atropine at 0.3 milligrams. So right there, you have milligrams and milligrams. And on hand, you have also some milligrams per milliliter. When it states per milliliter, that means per one. So 50 milligrams per 1 milliliter. How many milliliters are asking this particular drug that you would give? So they're giving a lot of extra added information here, and this is all you need to pull out of that question. So a lot of extra information there. This will end the podcast.